Hey guys, today I'm going to be talking about the hydroboration reaction in alkenes. It's a reaction I'm learning in my OChem 1 class. So if we look over here on the left, I'm going to be talking about the type of addition and regiochemistry first. The reagents you use in this reaction are BH3THF, and that's your first step. And your second step is a peroxide with a strong base. In this case, the peroxide's H2O2 and OH. OH is a strong base. So if we look at the type of addition here, it's going to be a syn addition. Syn addition basically means the stereochemistry of the things you're adding. So if you look here on the right, in this example, they're both on a dash, and your end product, the H and the OH that you added, are both on a dash. So if they have the same stereochemistry, it's going to be syn addition, and if it's anti-addition, they have opposite stereochemistry. Regiochemistry is talking about if it's Markovnikov or anti-Markovnikov. Anti-Markovnikov just refers to where the BH2 is going in this case. It's going to be going on the less substituted alkene. Normally with Markovnikov, your reagent aside from the H goes on the Markovnikov position, which is the more substituted position, and that's because it forms like a more stable carbocation. But in this case, it's going to be anti. And you know it's anti whenever you have a peroxide as a reagent. So regiochemistry is going to be anti-Markovnikov. And we'll see it later on as I do the examples. But if you look at this first example here that I have in this corner, you'll see that our first step is BH3THF. So what we're going to do for that first step is you're going to attach an H to the anti-Markovnikov position. It's going to be the more substituted position. So once you attach that, you'll also attach a BH2 to the less substituted position, which is what we have here, and they both have the same stereochemistry. They're both on dashes, as you can see here. And in your second step, you're going to have a strong base with a peroxide. What your strong base is going to do is change this BH2 to an OH, right? And then you're going to have a hydration right here. And yeah, we'll do some example problems down here. So in this first example, if we draw this to the side, we're going to attach the H to the more substituted carbon and the BH2 to the less substituted carbon. And that's because it's in the presence of peroxide. All right, so you're going to have a BH2 coming here. And actually, this will be on a dash because it's syn addition. BH2, and you attach your H here. Now, in your second step, that was your first step using the BH3 THF. In your second step, you're going to have the H2O2 and a strong base. What this is going to do is change the BH2 to an OH. So your final product is going to look like this. You're going to have this on a wedge, as that was in the initial problem. Your H on a dash. And the BH2 is now an OH. So this would be your final product for this first one. Now the second one, if we look at this, if we drew our perspective from here, looking at it from the bottom, we would have two ethyls going away from us. And that would be our stereochemistry of the starting product, starting alkene. In our first step, we're going to use the BH3THF. And in this case, because on both sides of the alkene, of the double bond, they're equally substituted, it doesn't really matter where you put the BH2 and H. So all right. BH2 and our H. And as you can see, they're both on wedges, and that's because it's syn addition, like we said at the start. Now in your second step, we're going to use the peroxide and our strong base, which is just going to convert this BH2 into an OH group. So if I draw that out, our final product will look something like this. With the OH on a wedge, and our H on a wedge. That's syn addition. So this is our last final example that I have here. I'm just going to ignore the stereochemistry of this because the double bond is there. But you're going to have this. This is your first step. So BH3 THF, right? So if we get rid of the double bond, or if we look at the double bond here, right, where's our more substituted carbon? It's going to be in this spot. This is a more substituted. Right, and then in the more substituted spot, that's where our H is going to go because it's anti-Markovnikov. So I'm just going to attach the H there. And then on the other side, we're going to have the BH2 on the less substituted spot. Once again, because it's in the presence of peroxide. And now our second step, right, we're going to have our peroxide and our strong base. And our final product will look like this. Our H is going to stay the same. And then our BH2 gets changed to an OH group. So that would be our final product right there. And yeah, thanks for watching.